So in this video we will discuss Heisenberg principle. So what it is that delta x, delta px, which got in the previous lecture already we have seen that span in the spatial coordinate and span in momentum space, somehow the product of those two were equal to h card. So actually in general it is a property of Fourier transform that the widths in position and momentum satisfy this relation. General form. And in the context of quantum mechanics, this is called actually Heisenberg uncertainty principle. So what it tells actually it actually states that we cannot prepare some state in which both the position and momentum of a particle can be defined simultaneously with arbitrary accuracy. But I mean, we cannot define the position and momentum simultaneously with the best accuracy. It should have some this type of constant. That it means that suppose if you try to increase the efficiency or accuracy in measuring delta x, then the measuring delta px will be decreased. So you cannot measure simultaneously with arbitrary accuracy. So okay, so that's all. So now we'll discuss the bound states and scattering states. I think everything is visible. Okay. So now what is bound state and what is scattering states? So let me first define it in terms of energy and potential. Okay. So you suppose I mean you know it that of every particle has some energy, total energy, anti-energy, you can say, and if I obstruct the particle with some potential barrier, then there will always be a possibility that the particle may cross the barrier, may not cross the barrier, right? Like that. If I write in this way, suppose energy is V precisely defined. Suppose it is at infinity, minus infinity, and V plus infinity. If any is less than this potential barrier, then we call them bound states. Okay. Now, and vice versa. If it is greater than, then we call it scattering states. So with a picture and with some figure, it can be more understandable. Okay. Suppose if I draw this way, it will give you the trajectory of the particle. Now if I draw the energy curve, okay, and I define this is suppose x-axis. Okay. Now this is the potential values. Suppose this is the total energy. So then we call this state bound state. These are the actually classical turning point. Those are called classical turning point. Okay. So they are classical turning point. Now suppose in another figure, if I draw suppose in this way, and this is the potential, and this is x-axis, this is ds. Suppose this is the E. Okay. Now you can see here in the trajectory of the particle, this MC is the, you can see energy is greater, so there will be only one classical turning point. This is classical turning point. Okay, this is the classical turning point for this case. So here you can see that the particle can easily travel through this path, but cannot travel through this path because it is the total energy. So this is the turning point. So this is the bound state, while this is scattering state. I think now it is clear to you that bound state is another one interesting thing is there. That is in quantum mechanics there is another interesting term. It is called tunneling effect. So what is that? Suppose the case is like that. Let me draw first. So okay. This is suppose energy. Okay. Suppose the case is like, I don't know how to finish. Now this is the energy, and this is Px, and this is x. Now these are the classical turning point. Yes, classical turning point. This is also classical turning point. So here with some condition, a particle can travel, or you can not travel actually. Particle can leak through this potential area. That special phenomena is called tunneling effect. So gradually, when we will solve different problems, finite potential well, infinite potential well, or other problems also, then we will understand the matter very clearly. So to solve this type of potential well problems, we need two main boundary conditions. To solve the wave functions actually, precisely, so we need two main boundary conditions. So one is at the boundaries. So if I say boundary conditions, so first boundary condition is that psi wave function is always continuous in the boundaries. Second one is d psi dx, okay, is continuous at the boundaries only when potential V is not infinite. Means if potential is infinite, then d psi by dx is not continuous. So using these two boundary conditions, we will solve the other problems. And so when we will solve those problems, we will understand the application of this boundary and actual understanding of these bound state and scattering states.